Finite Math, Section 2-1, Part 2. So we're going to continue with the Gauss-Jordan method, and a lot of times I call it Gaussian elimination. Gauss was the guy that came up with it. I got a really good story on Gauss, but I'm not going to bore you with it right now. I'm going to ease this into you slowly. Make sure we got the basics. So let's say I've got these systems here. I want to write each system of equations as a matrix. So again, what you're going to do is you're simply going to get rid of the variables, the plus signs, and the equals. So on the top equation, I got x plus 2y equals 3. I see 1x plus 2y equals 3. And the bottom, the numbers are going to be -5, 4, and 1. So I'm coming up with that rectangular array of numbers. It's a matrix. I'm writing the equation in matrix form. On B, it's going to be 1, -6, and 4. Bottom row is going to be 4, 3, and 7. Now they're pretty easy when they're 2 by 2s, and you'll find when we go to 3 by 3s, they get a little bit tougher. So here I see 1, 2, 1, and 18. 1, 2, 1, and 18. On the next row, I see 2, -1, 3, and 7. And the bottom is going to be 4, 1, -1, and 6. Very important as you're doing this, try to make sure you can see your rows and also your columns. Keep them lined up. That's a rectangular array of numbers we're talking about. If you don't do that, then you get confused when you're working your problems. Okay, in the last one, I see 3, -7, 1, and 5. Look at the second equation. We don't have any y's. So I have 4x, I'll put a 4 there. I don't have any y's, so that's 0y, so 0 goes here, and then 1, and then 10. And then on the bottom one, there's no x's, so it's 0x, 2y, 0z, and 6. Okay, so making it into a matrix equation is not very hard. Okay. Now we want to talk about taking these matrices, that's plural, and putting them into, I call it row reduced form. This book calls it diagonal form. It's okay. It really doesn't matter. Now, what does that mean, row reduced form? Well, that means it has a 1 in each location on the main diagonal of the matrix. Let's skip down in here. Here's a 2 by 2. Here's the main diagonal. There's your 1s. Number 2, except for the last column, the remaining locations all have 0s. So my 1s were here. See the 2 zeros? And then there's going to be 2 numbers right in here. We don't know what they are yet. But the last columns, once we figure that out, those will end up being my answers. Going down here, here's a 3 by 3. So you can see your main diagonal. I got in the red, 1, 1, and 1. Okay, forget the last one. Now if you take out the 1s on the red line, notice how everything else is 0s. That's row reduced form or diagonal form, if you want to call it that. And then whatever your 3 numbers over here will be, those will end up being your answers. And I'm going to show you how to get those. It's kind of like a game. We're going to take the matrices. I'm going back, this is my example from the other page. We're going to work these numbers. There is, like I said, it's a game and there's rules you can follow. And we're going to change these numbers until we get to a point where we have 1s on the diagonal, 0s every place else, and then whatever we find these numbers to be, those will end up being your answers. Okay.